Welcome to another VirtualX MasterClass, looking at trigonometry in this session. In particular, the latter part of our trigonometry called the 2 or 3 dimensional problems, which we refer to them, the topic is Triangle Formulae. Remember the topic, the trigonometry that we were doing, where we even use some definitions like cos, SOHCAHTOA, sine is opposite over hypotenuse. When you talk of hypotenuse, it simply means that we are talking of a right angle triangle. Now, this kind of trigonometry that we are entering into is the trigonometry that we use when we don't have a right angle triangle. So if you look at triangles and you see one triangle that's got a right angle triangle, I'm going to use SOHCAHTOA there, my definitions. If another triangle does not have a right angle triangle, I'm going to use this topic called Triangle Formulae. Remember, it is only 3 rules. You can't fail 3 rules. The first rule is called sine rule, the next rule is called cosine rule, and the last rule is called the area rule. If I have this triangle, for example, if I have this triangle, if this is A, if this is B, this is C, the side opposite this C we'll call small c, the side opposite this will be small b, the side opposite this one will be small a. Remember, this section you'll be looking maybe for sides or for angles. Suppose we are looking for a side. I will start with the side. If the sine rule says A over sine A is equals to B over sine B, also equals to C over sine B. Most cases you'll be given then you'll need to find the value of that side A. So you'll cross multiply and find the value of A. That's how you use a sine rule. Remember these rules, these 3 rules, sine rule, cosine rule, and area rule, only work on a triangle which is not a right angle triangle. Let's look at the cosine rule quickly. Cosine rule, how it works. If I give you this triangle, A, B, C. This side is small a, this side is small c, this side is small b. When do we use the cosine rule? We use the cosine rule when we are given 2 adjacent sides and an included angle. Let's make an example. If I'm given this side and the value of this side, I can't be giving this angle or that angle. I must only use the angle between the 2 given sides. We call that angle the included angle. So for me to use the cosine rule, I must have 2 adjacent sides and an included angle. If I have that, I use a cosine rule. But if I don't have that, I will use a sine rule. Now, what does it say? If I'm given that and I'm looking for this side B, what is the rule saying? The rule says b squared is equals to this side squared, which is c squared, plus this side squared, which is a squared, minus 2 of the first side, which is c, the second side, which is a. Because we're talking about cosine rule, it will be the cos of the included angle, in this case, which will be p. This is what the cosine rule is saying. This side squared is equal to L side squared times L side squared, or plus L side squared. I repeat, this side squared is equal to this side squared plus L side squared minus 2 of this side times this side cosine of the included angle. That's how the sine rule works. Let's go to the area rule. Remember, there are only 3 rules. It's the sine rule, it's the cosine rule, and the area rule. Remember, when we'll be asking you about the area rule, we'll give you the same conditions as in the cosine rule, where if this is A, this is B, this is C, maybe you'll have this angle, you'll have this side, you'll have that side. So what is the area rule saying? Number 1, when do we use the area rule? When the triangle is not a right angle triangle. Because when the triangle is a right angle triangle, we know the formula, half base times perpendicular height. If it is not a right angle triangle, we use the area rule. Area of this triangle ABC is equals to half L side, which is AB, times BC, sine of the included angle. This is what we call the area rule. So you'll be applying these rules in this section. Remember, the question is, when do we use the area rule? You only use the area rule when, number one, when the triangle is not a right angle triangle. And you must be given two adjacent sides and the included angle. The area rule is clear when the question is asking you to find the area and the triangle is not a right angle triangle, we use the area rule. Let's come to the next two rules, the sine rule and the cosine rule. Let me start with the cosine rule. When do we use the cosine rule? When you are given two adjacent sides and an included angle, then you can use the cosine rule. When do we use a sine rule? If you're not given two adjacent sides and an included angle, then you'll go and use a cosine rule. Remember, this rule only works in a triangle which is not a right angle triangle. Let's look at how they set this in an examination. Remember, this is a three-dimensional problem. Usually what you see there is the bottom view, this is the front view, and this is the side view. Hence we refer to it as the three-dimensional problems, because I can see three dimensions there. Now, as I look at these dimensions, focus on the triangles that you see there. When I look at the front view, I see this triangle. What type of a triangle is this one? It's a right angle triangle. I see another triangle here, I can see it here. It's not a right angle triangle. So when I deal with this triangle, I'll be using this section triangle formulae. It's either sine rule, cosine rule, or area rule. But when I deal with this, when I'm dealing with this triangle, I'll be using Sokatowa, my definitions, because it is a right angle triangle. When I deal with this third one, it is also not a right angle triangle. Hence, I'll be using these three rules depending what the question is looking for. Let's look at the first question. And even the marks are important. If you look at this one, find the length of LB. Find the length of AB. This one is 2 marks. This one is 5 marks. What is this saying to me? The section that I'm dealing with is triangle formulae. It's either sine rule, cosine rule, and area rule. This question is not asking me about this topic, but that one is asking me about that topic, hence the bigger marks. So when you start with, I'm just giving you tips for examinations. When you look at the marks, there are 2, so you can't go and jump into cosine rule or sine rule or area rule. Go back to your grade 10, use the definitions, you'll be able to solve it. Length of LB. Let's look at LB. This is the length, this is the distance that we're looking for. The length of LB, this is what we're looking for, this distance. Right? This distance, it can either be in this triangle or that triangle. You'll go and find the difficult way in that one. The marks will guide you. If it is 2 marks, you use the right angle triangle. Let's look at the right angle triangle that we have there. This is the right angle triangle that we have. Therefore, it is important, learners, that you must tell the examiner which triangle you are using, so that they will focus, because I might be looking, you might be working with this triangle on LB, but I'm also looking at this one. I thought I'll be working on this one if you don't tell me where to focus. So it is important that you must tell the examiner to go and focus in triangle HLB. HLB. What type of a triangle is HLB? It's a right angle triangle. So I know that I'll be using my definitions. So, Towa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So I'm focusing on this triangle. What is it that we have on that triangle? We've got this angle here, which is 40 degrees. We've got the side that is opposite. Which side are we looking for? If this is the angle and that is opposite side, what do we call this side? It is called the adjacent side, next to. Adjacent means next to the particular angle. So this is the angle, this is opposite, this is adjacent. This is what I'm looking for. Am I looking for HB? No, I'm not looking for that. But what is it that I'm looking for? I'm looking for the length of LB, which is this one. So in this particular case, I'm not concerned about my hypotenuse. Number 1. Now, how do I go about finding LB? I've got to use the ratio that will include LB. What is LB? It is the adjacent. I see adjacent here, I see adjacent there. So I can either use this or this at the moment, but you can only choose the best one, 1. Now watch, am I looking for the hypotenuse? No. So any ratio that has an hypotenuse is out. I see a hypotenuse here, I can't use this one. I see hypotenuse here, I can't use this one. So this is the one that I will be using. Because I don't need the hypotenuse, I just need the adjacent. Let me define this. Tan is opposite over adjacent. Tan of 40 is opposite over adjacent. Let me write that one down. Tan of 40 degrees is equals to TOA. It is 3 over this side, which is LB, the one that I'm looking for. Make LB the subject, cross multiply, take this side, you divide that one by this one. Then my LB will be equals to 3 over tan 40 degrees. When LB will be equals to, put this in your calculator. I've got 3 divided by, where's tan here, tan 40. 3,58 meters. This is the distance LB. When you're dealing with this section, boys and girls, whatever dimension that you've calculated, put it in the diagram. Once you put it in the diagram, it will make your life much more easier. Let's put this 3,58 meters where it belongs. 3,58 meters. Right, that's the distance we got. Let's look at the next question. There we're required to find the length of AB, and it is 5 marks in this particular case. Length of AB, and it is 5 marks. All right, let's work it out. Length of LB. Let's go to our diagram and see where LB is. The length of AB in this particular case. We're looking for this length AB. And this AB is, of course, in this triangle. It is in this triangle. That's where AB is. I'm looking for this distance AB. This is what I'm looking for. Let me highlight it in that way. Look at it. It is in which triangle? I'm telling the examiner that go and focus in triangle ALB. You always tell the examiner in triangle ALB. This is where I'm going to find my solution. Remember, I'm just looking for the length of AB. Now, where is AB? What type of a triangle is AB found? This is not a right angle triangle like this one. Therefore, I can't be using SOHCAHTOA on this one. What do I use? I use these 3 rules. Is the question asking for the area of this triangle? No. Therefore, the area rule falls off, because I'm not looking for the area in this particular case. I'm just looking for the length of AB. So I can either use sine rule or cosine rule. Now I look at my diagram. Your eyes are the most powerful tool in your mathematics. When you look at the diagram, you check what you have and what you don't have. In this particular case, we've got this side, we've got that side. If I did not write this dimension down there, it was going to be difficult for me to see that I also have that side. Because as I write, I forget. As soon as you get this dimension, go put it in the diagram. Why? So that you can see what you have. In this particular case, we've got this side, we've got that side, and the included angle. Which rule do we use when we have 2 adjacent sides and the included angle? Of course, it's the cosine rule. So I know exactly which rule will I use. If I did not have 2 adjacent sides and the included angle, I was going to use the sine rule, depending on what is required in that particular case. In this particular case, we're looking for AB. We know that the cosine rule says this side squared is equal to this side squared plus this side squared minus 2 times this side cosine of the included angle. Let's write that down. This rule will be saying, remember, we're looking for AB. We know that AB squared will be equals to AL squared plus LB squared minus 2 of the first one of AL times the second one, which is LB, cosine of the included angle. In this particular case, it's going to be cos of L. Next step, I substitute AB squared. Let me just do it like this and say AB is equal to the square root. I'm trying to get rid of that squared. So what is AL? I'm substituting now. What do I see on AL? 5,2 meters. I've got 5,2, which is squared, plus what do I see on LB? LB, it's 3,58 meters. If I got this one wrong, I will get this next problem wrong. So make sure that you do the correct calculations there. So LB, I have 3,58, which we calculated. 3,58. Yes, this is also squared, minus 2 of the first one, which is AL, which is 5,2, times the second one, which is 3,58, cosine of the included angle, cos L, which is 113, 113. From there, you go straight to the answer. You don't do so many steps because you'll make mistakes. Number 1, you write the formula. Number 2, you substitute. Number 3, you take your calculator and write the correct answer. Let's do this thing. Then you press your calculator. You press all the values that you see. Then you press your equal sign. It will give you 7,3759. Correct to 2 decimal places. It will be 7,38 meters. This is how you go about using your cosine rule. Remember, the diagram was helping me. If I'm using this triangle, there is no right angle triangle. So it's either I use sine rule or cosine rule. The last question, 7.3, says calculate the area of triangle ABL for about 4 marks. Calculate the area of triangle ABL. What is the question looking for now? The area. Let me go and look at triangle ABL. ABL. It's the same triangle that I was using. And I'm telling the examiner, I'm going to find my solution in triangle ABL. What type of a triangle is ABL? Is it a right angle triangle or not? ABL. Oh, this is not a right angle triangle. And the question is specific, looking for the area. Therefore, I'm going to use the area rule. Remember, the area rule works hand in hand with cosine rule. You must be given 2 adjacent sides and the included angle. The area of this triangle will be equal to, area is equal to half of left side times left side sine of this one. The area uses the ratio sign. So the area will be equals to, let's write it down, area of this triangle will be equals to half of this side, which is AL, times the other side, which is LB, sine of the included angle, which is L in this particular case. This is what referred to as the area rule. Let's substitute. Then our area will then be equals to half. What is AL? It is 5,2 times LB. What is LB? It is 3,58. Sine of L. What is L? It is 113. Then area will be equals to, you go to your calculator, you don't do anything, you just punch your calculator, it will give you answers. Remember, it's a half, it's 1, go down over 2, into, what do we have there? 5,2, 5,2, close this bracket, open another one, 3,58, 3,58, close it, sine 113, where is sine 113. You close that bracket. Yeah, sine 113. What is the answer that I'm getting? I'm getting 8,57. This is in it is meters. Remember, this area is square unit, so it's meter squared. So this is how you go about solving these 3-dimensional problems. But I want us to take another one which is slightly different than this so that we can practice more. Thank you.